Hi everyone, my name is Alicia and today we're going to go over paired samples t-tests. So just to give you a little bit of the background information, I have some data on different students and you can see we have a before score and an after score. Basically, the reason why it's called paired samples is because these before scores and then this after score are paired with this student number one. So these scores are related and taken before and after, so at two different times. So this is the reason why we're using a paired samples t-test. So what I'm going to do first is I'm going to have Julius bring in the data because this, of course, is the very first step. So Julius should read in my data set and it's examining the resources. And then after that, we are going to look at descriptive statistics on both of the before and after scores. So as you can see, it brought it in, no problem. So let's go and so this should give me a rundown for each student and their before and after scores and some descriptive statistics about that. Great. So as you can see, for student, we have about 20 of them. So the before score usually, and then the after score, we have about 20 of them. So it looks like the mean before score is actually 153.2 and after score is 143.95. So we got the standard deviation, the minimum values for each of the before and after score, and then we have the maximum, which looks like it's 165 and 155. We also have interquartile ranges in 25, 50, and 75%. So now that I've explored the data set a little bit, I'm going to ask for, actually, I'm going to choose this result because we always want a histogram because this is going to tell us the setup of our data set. So let's do the histogram. Okay, so actually that's new. I haven't seen it prompt like this. So let's do, I only want it for before and after score. So let's ask it. So the reason why I'm specifying to be on separate graphs is because it's easier for me to kind of see the distribution of each one separately than together. Sometimes it gets a little crowded if it's together, so. Oh, that's nice. So before score, it looks like it's slightly skewed, so we'll check. This one also kind of looks like it's slightly skewed too. So let's check to see. So I'm gonna now run, well, first I'm actually gonna ask, what? So this just helps me keep everything together, and it also shows you that the different assumptions of the paired t-test. So we have paired observations, like I've already kind of told you in the very first or the beginning of this video, that these observations are paired because we have the before and after scores. They are continuous observations. So it looks like we're going to be looking for normality and outliers. So performing these tests on both of these columns separately at least will tell me how normal, so taking that histogram that we had in the beginning, it will show me if my data sets are normally distributed. Because just taking a glance at it doesn't totally give us an idea on the set of data. Well, it gives us a little bit, but I would like to have some kind of p-value associated with it. Okay, awesome. So they actually are normally distributed. And it looks like for our outliers, we don't really have any outliers for either of them. So this means that running the paired t-test between the before and after scores should be okay. So yes, let's perform the test, the paired t-test on the before and after score columns. So perfect. Okay, so now we can see that the p-value from this result is statistically significant. So what I would like to do now is create a graph that shows the statistically significant differences between the before and after groups, and it shows an asterisk that actually conveys this message. After that, I'm going to calculate the effect size to see what the magnitude of difference between these scores are. So let's start with that. So paste. I'm going gonna submit. So the reason why I'm saying asterisks in this specific visualization is because if I do not denote that in Julius, it might not create the correct visualization that I want. So, and it's troubleshooting itself, which is fine. Great. Awesome. This is a beautiful visualization. The only thing that I'd change is adding another asterisk on the top to show very statistically significant differences. So what I can ask for that is I'm just being nitpicky here. That's okay. You don't have to be as nitpicky as I am. But usually anything that's under 0.001 gets a double asterisk. I could have gone in through the code itself actually and changed it, but I'm just asking Julius to add it in. That's perfect. You can see it's right here, and that's fantastic. So the next thing we're going to ask is to calculate the effect size. So let's ask Julius this. So we get an effect size of 1.849, which indicates a large effect size, suggesting that there is a substantial difference between the before and after scores. The last thing I'm going to do is ask it to report all of our findings. So this is just adding the finishing touches onto our findings that we found. So it's going to give me the descriptive statistics as well, which is great because then you can add this in. It gave me the normality test. So it also is giving me the outliers. So this is just giving me a lovely rundown. This is how we would report the paired t-test. And then we have the effect size here. So this has been how to run a paired t-test in Julius. I hope you now understand how to effectively run through all the steps and perform this data analysis.